Okay. Okay, so welcome back everyone to another Serenum stream. So last time we managed to get some textures that we created rendering on the Serenum. So in particular, just as a refresher, when we went into we created a sprite using a program that has been basically written from scratch in Zig. This was the sprite here. This typical image viewer doesn't actually zoom in properly. Zig image viewer roof PNG. We made this using an app called Pixie, and then we spent a couple of streams trying to figure out how to get it onto the Serenum and then render it. But we did that. And so the current code that is rendering this sprite was crafted with the use case in mind that we're going to translate this down into RISC-V assembly. So for instance, if I jump to the source code of that now, let's first get rid of this application. Then we want to do a scripter m texture ASM. This is the code that rendered everything on the screen. And in particular, our function for drawing the sprite, our procedure for drawing the sprite is just this. And so today, this does the job, but since it's not raw assembly and the Brevis compiler is still fairly early on, the compiled code for this won't be sort of as optimized as it could be if we just write it directly in assembly. And so today I want to do that. I think a first cautionary step to do in this is to write in some code that just makes sure that we won't get any out of bounds error issues when we try and draw this. For instance, the person who's passing the coordinates doesn't pass in -10 for the top left coordinate of the pixel. That will clearly be out of bounds. So I just want to add in to a higher level function something that kind of checks that, and then refuses to draw the pixels unless we can be certain that every sprite of the pixel is actually going to go on the screen. And then once that happens, we'll then call our assembly function that will translate this code into today to then get that to the screen. And then that will probably take most of today, but if we have time, I then realized that there's a very, very simple game that I want to make using this new functionality that will take even less time than the Serenum Sokoban that I'm working on at the moment. I kind of underestimated actually how large the Serenum Sokoban was going to be in terms of the effort. But this kind of app will be take a significantly shorter amount of time to make, at most 50 hours at least, to get something somewhat kind of polished. And then I want to get that out so that by the time that the Serenum's Wi-Fi capabilities are activated, I can then ship out the puzzle game to everyone else in the world who's using a Serenum. However, to do that, we must get this source code working. So the first thing to do is to add in another procedure, which is going to be the thing we'll eventually translate into assembly. Then we will compile that, make sure it works. We'll then add in the kind of safety check that the sprite isn't being drawn in a silly way. Check that works, and then we'll start translating everything to RISC-V. So let's just begin by writing a procedure called draw sprite ASM. And here we really need to think about what arguments we're actually going to be passing in to our assembly procedure. So I think we just want 2 pointers. One is like the frame pixel pointer that we've already calculated up here, and likewise the sprite pixel pointer. So we can have our frame pixel pointer, and then our sprite pixel pointer. Then we're going to need our assembly procedure will need some other arguments to know what to do. Why don't we pass in the width? Let's see. Yeah, like in the RISC-V, all of these lines, all of these registers, at least on the Serenum, are 64-bit. So we can just include the width, the height, and finally, what else do we need? I think we just need to add in like the next line increment. So we'll keep that like an S64 as well, or maybe just like line new line, or like everyone knows what it means if we label it like this. The next line increment. Okay. Okay, so now let's just copy in our loop. So now we just want it to be a height, next line increment, just the width, and then those things. And then here we'll want to call the this part we can rethink what we need to do, but for the meantime we need to check that the sprite won't cause an out of bounds error. And then here we want to call what it actually is. So now we're saying draw sprite assembly, and yeah, we're passing in the frame pixel pointer sprite pixel pointer, then and the sprite dot width. Where's the dot? Sprite dot height, and the next line increment. Okay. So yeah, so let's figure out how to do the assert stuff. So yeah, so last time Sam noted that if we want to do an assert, it's as simple as calling add firma and then putting the an inline comment with the condition, so that when it fails, it will get printed out. So we have that at our disposal. But I think I would kind of prefer for like if the sprite is out of bounds, for the function to simply return and not actually cause a crash, but instead to print an error to kind of stand it out, saying, hey, like you're trying to print this in a silly way, stop it. Okay, so yeah, so where should we begin? Okay, well, what needs to happen in order for the sprite to be fine? In order to be drawn, like the top left corner needs to be within the bounds, and then the bottom right corner needs to be within bounds. And then if those two are within bounds, everything else should be within bounds, I think. Yep. And then, so those are the only two checks we need to do. So let's first check that the top left corner is within the frame boundaries. And then likewise, we'll do the same for the bottom left. I mean the bottom right. Bottom right. And then, yeah, if not, we're going to return. But this reminds me again, how exactly do we return from a procedure? What is the keyword again? We can look it up if need be. We did this a lot in our Sokoban. Let's just like somewhat cheat and just fast track what it is. If we do like the Serenum backups, it doesn't really matter which one. And we do like some kind of switch statement. Maybe it's actually faster to look at this on the Serenum. I think it will be. Okay, we want to do Sokoban, the codecs, and then just load that in read-only mode for the moment. It must be like refer. Let's return. So yeah, so we could say see if the TLX is less than 0, or how do we do the or again in this language? Maybe it's just a single one. Or TLY is less than 0. Then we simply return. maybe this itself can be like inlined. And that's all we need for that condition. And then if the bottom right corner is within the frame, we just need to check that the TLX is greater than, well, what would this be? Frame dot width. So what is like the type of frame dot width? We might need to cast each of these. Or, oh, hang on. In addition to each of these, we should print a like warning message that things are failing. We'll add that in. Add that in soon. Or TLY is greater than S64 frame dot height. Likewise, we'll do a return an error message. Okay, what error message should we print? Let's say which array error, well, maybe not error, but like warning. Attempted to draw sprite off the frame. And then let's just put in what the coordinates are. TLX, TLY are equal to something and something. Where here, yeah, we just print in TLX. Oh, there's a bug in like the lines below that I just realized belatedly. Hey J Robbie, thanks for stopping by. Yeah, I haven't seen a procedure statement in a while. Are you coding in Pascal? No. This is actually a custom programming language for a from scratch computing system known as the Serena. And so this is a system that's been developed like from the ground up. It's completely kind of self-hosted. Where's the latest? Yeah, it's if you go to this page here, like the Serena, it will kind of show it. But it's basically a solution to like the 30 million line problem. And so yeah, it's from, like in particular, the operating system is completely from scratch. For instance, if I like exit out of this, you can see what the operating system looks like. This is it here. Yeah, I can like compile programs, everything, and I'm now just exploring, drawing textures with it. But yeah, the operating system will never have drivers that will stop the code base exploding. Everything's done in RISC-V, which is an open ISA. So no one has to pay commissions to like Intel or AMD or whoever in order to sort of provide appropriate low-level support. Yeah, it's my kind of thing. Yeah. Okay. So yeah, but yeah, thanks for asking. Okay, so now we've like printed that warning message, returned. Yeah, so the bug with this line is that we don't want to be checking that the top left corner is larger than the frame width. We want to be checking that the bottom right corner is out of these bounds. Okay, but these bottom right corners will need to compute from the top left corner information in the width. So let's just say bottom right corner is equal to the top left corner plus the sprite width, and then the bottom right y is going to equal the top left y plus the sprite height. Okay, so now it's in there. We can then say, yeah, if both of these are bigger than the corresponding things, we'll just print the same error message as before. Okay, so now then that's done, we then proceed to do the actual calculations to figure out these pointers. We should also do an assert that the length of the texture is the same as where we're kind of getting it from. So, but maybe there's actually not a need to do this. I feel like it wouldn't hurt, so maybe we should just add it in here just in case. So we want to do this add firma condition with the macron on the A. Okay, so add firma condition with a comment. So now we want to say sprite dot, well, what is it? It's going to be which is called the sprite pointer. So this is a pointer to an array. So let's just say the length of that. We want to double check the length of this is equal to the sprite dot width times the sprite dot height. And then if it is, if it's not, we want to say, ooh, this might cause an out of bounds error. We want to fail this if the width and the height is greater than the length. But if it's underneath the length, I guess it's I guess if the width and the height, if the product of the width and the height is technically less than the overall length of the pixels, because we're just drawing the top left portion of this, we're drawing some sprite in some weird way that won't cause an out of bounds error. So I guess we could have a warning in that case, but we should fail it if the width and the height is greater than the length. And I guess we should actually do it before all of these calculations. And we should say check that check that the the easiest thing is actually just to fail this if the lengths are different. I kind of want to do that instead. So we might just comment this at firma and do it. Keep it there just so we know the syntax. If there's ever some use case where you need to only draw part of a texture, we'll adapt it then. Check that the sprite data length length matches the the sprite dimensions. Okay, so yeah, so we simply want to say single again, C sprite dot sprite pointer. If this does not equal the sprite dot width times the sprite dot height, then fail it. And fail it with another warning. Actually, with all of these error messages, we should also print something that says like not drawing sprite, maybe. Actually, maybe it's fine. Sprite data length does not match dims. So yeah, so let's say we then just have so we can say if we have like the data dot m width and the height. Let's say surely this is just like the sprite dot sprite pointer dot length, then the sprite dot width, a DTH, and then the sprite dot dot height. Okay. Okay. So now I've done a due diligence that we're not going to cause a program crash when we try to draw this sprite. And these calculations are like kind of negligible with the cost of actually drawing the sprite for the moment. Let's try and compile this and check that stuff is still drawing. Okay. So what do we want to do? We want to do compile, or maybe we already have these commands from last time. Yeah, compile texture ASM to that one. That's what we want. Oh dear. Type mismatch, N8 and S64 line 105. Yeah, because clearly I'm not taking the length of these. Is that? Hopefully that's it. I spoke too soon. Type NA does not have members through a pointer. Oh. Okay. So yeah, what's going on here? I thought when we embed a file, the pointer that gets like returned to it is not just to like the start of the file, but like an array. That is concerning. Yeah, like this line up here, I thought this is... Oh, I guess we're like implicitly casting it in some way up here. Okay. It would be a lot more sensible to consider this as to change the type of this to what we kind of actually want it to be. So this will result in us having to change some of the code, but it would be way better, since this is a sprite pointer, for this to be like a spadia of pixels. What is the syntax for this though? I've already forgotten. If we go back to this, so I think we could just say, yeah, like square brackets type name. Okay, so if we instead consider this as M32, we'll now need to initialize this appropriately. So down here, this line will have to change. But even calling it like sprite pointer is a bit off now. So why don't we call it like spatium? Or actually just like pixels. Pixels is the easiest way to consider this. Sprite.pixels is kind of what we want. And we'll just remember that pixels are a spatium. But since they are a spatium, we need to fix this thing. Oh yeah, thanks Jay Robbie for for asking questions and checking things out. Sorry as well that my internet connection is so terrible, and so presumably the frames are getting dropped on the stream. But yeah, I'm enjoying my time with the Serenum, and if you have a chance to sort of check it out too, and if it looks like something that you like. Yeah, it is an exciting project, that is for sure. Okay, so we now need to figure out what to do here. So I think since the spadia are the spatium type is just, well, what is it? It just has a length and a pointer and presumably a type. So the type's already kind of encoded in our declaration of it in the struct. But how do we fill in like the member information? I think Sam posted about this before. Yeah, like array.m short for magnitudo. But you can assign these things separately. Okay, let me just like look up this on Discord. If I put this like above everything, then Even when I like search it, I shouldn't see it. So what are we doing? We're doing oh wow. I'm kind of happy you didn't see me right click on Discord and there was literally a 1 second lag to copy it. Oh my goodness, like it's software these days. Rebuilding is needed, which is why we are doing stuff in this arena. Okay. So yeah, so Sam has noted these kind of lines. I and M is what we want. So if we do the dot M to be like the length of what it needs to be. Like in some sense, we're like baking in some sense this check is not really is like being done at the wrong place because it's just checking that say I do assign this as 25 by 25, it's which it should be able to do. The compiler would handle that. It's just checking that I'm actually multiplying these things correctly, but which is happening by definition. But we'll use this for the moment before we. It doesn't seem like there's an immediate need to change this. Okay, and then we now get the RISC-V data, and the size of the pixels is that. Okay. Okay, so now those two have been done, we can modify the rest of the code that's needed to now use the fact that this sprite struct is using a spatium instead, and is also like using pixels instead. Okay, so yeah, this code remains unaffected. This should also be unaffected. This stuff though is different now. It's now pixels. So this should be pixels here too. And then I should have mentioned to like Robbie that there's also a Discord. Oh well, something for next time. So yeah, frame.pixels. So here it should be like .i. Are we gonna have to cast this? Maybe. Actually, maybe it will be fine. Okay, frame width, sprite width, da-di-da-di-da, that's fine. Sprite.sprite pointer. Okay, the sprite pointer is now pixels. .m. Okay, that was a comment, but whatever. Frame pixel pointer. Okay. There's probably something I've missed in here, but we'll get the compiler to check it now. Okay. Okay, we are getting this mismatch. So I think we can just cast this. Surely we can cast that fairly easily. So that's line 57. Okay. Okay, now we're getting an N64 and S64 issue. Watch out, Nintendo. A different hardware competitor is using the phrase N64. So how do we fix this? I think we just cast the left-hand side to S64. So this is line 106. Okay, and then if that's happening, the line above it was okay. So okay, I'm doing all of this, but at the same time, I'm thinking like, in the struct itself, we should just immediately ban like a negative width and a negative height. Like we should just make both of these positive to begin with, and then that will avoid this cast. But we will need to cast these two to S64s to signed integers in some of these other calculations. I mean, or do we? That's the thing. Instead of casting the frame width to like an x64, if the frame width is itself like an n64, the sprite width will be that as well. So that just avoids a cast operation. Okay, this line kind of does need casts though. But again, even then, like for like the top left and the maybe the way to go is just to like keep everything signed, and then only when we call it on the assembly do we actually cast everything. I feel like that's kind of the way to go. Oh, but okay, the reason is if we're doing any kind of game programming stuff, these like top left coordinates are probably going to be signed anyway. It would kind of be annoying to have to like cast stuff every time in like a render frame that we want to draw a sprite. So we might actually keep these ones signed. Alright, so then so these stuff have to be signed, so we do have to cast those. Everything there is fine. Here we do need to cast that. Oh, talking about things I missed. I think if we just say it's like the I, we don't even need to cast that at all since it's already going to be an N32. Let's see. That should be fine. And then what's happening here? Okay, so here we do need to cast some stuff. So we want to say this is now a next 64, and this is a next 64. Otherwise, things are fine. Okay, let us compile, try to compile again. What's the next issue? Okay. Oh, those really weren't actually fine. 97 and 98. So now what's the issue? Genus N32 per Elysium member non-habit. Not have members through a pointer. What? Oh, of course, because that's like framepixels.i. Duh, that doesn't need anything. Okay, 112. Yeah, that's fine. That's framepixels is its own data structure. It's not ours. Okay. Next line increment expected as 64, but instead you've given it an at N32. That should be changed back to next line increment should never be like at N32. We should just cast that when necessary. So let's change that. So both of those things need to be casted, but we can actually just cast the entire thing. Since both of these are now like positive, divided by 2. Okay. This is like the Pareto principle all over again. It's like actually writing like the code that draws it fine, and then in order to like make it safe and translate it down to the assembly, it's like it takes so much time. Okay, what's this? All right, now I don't know what this is. Oh, there's like a missing parent. Oh, I forgot a semicolon. Line 119. So yeah, what are we doing? So we're doing, it was 119, it's meant to be a semicolon. Okay, now I have to do like move the cast down. So yeah, next line, we need to cast next line increment to at n32 here. 129. Like we're about to translate it into assembly anyway, but like this is, we'll keep a copy of this. So yeah, it should be at n32. So maybe really this shouldn't be called ASM, this should be called like pre-ASM. And then so we can have a copy of the code floating around. Need be. Okay, this looks like it's going to compile. We'll see if it runs, and then we can get on with translating this into assembly. So now we want productor, texture, ASM, didn't crash. We're going to have to like lower the resolution from, okay, things are drawing, that's great. From this super high resolution it takes a while to load. So yeah, quit out of this, edit this. So we want to change like the view mode from 3 to 1. Noob's graphics setup from 3 to 1. Okay, and great. So now this is working. Now we can, yeah, begin to turn this into assembly. So, let's copy that. Now replace this with ASM and get to work on doing this. So, previous streams we figured out the current best way to do this using the internet. There's a bajillion RISC-V emulators. Almost all of them are terrible, but we found the version that was the least terrible. So let's let's like turn this from like full screen into like windowed, I guess. And then switch back to our clicky keyboard. Okay, so like the good assembly, like the not terrible RISC-V emulator was this from memory. Where is it? Yeah, this was the one. So let's write where's like PowerShell? Come on. This one, open terminal. So let's do like what, like texture, draw texture. Yeah, texture ASM. Dot. Maybe we can actually call it ASM. We want to open this with Emacs. Come on. curious, run Emacs. Why isn't Emacs running? Okay, run Emacs. Draw sprite ASM. Okay, kind of working. So let's open what we did last time as like a language reference. Where was this? Do we just like, where did we do this? I feel like it was this draw disk ASM sketch, maybe. Yeah, this kind of feels correct. And then what was the slides we found? This is what we wanted. Great. I think this is all we need now. So let's like, there's so many windows open. Let's remove some of the clutter. Okay. All right. So yeah, we can copy a lot of the same setup. Wait, what just happened? Okay, so let's like choose some like example thing to set this up with. So as an example, we might be calling draw sprite ASM. Let's draw this like where did the memory begin in this emulator again? Was it like 100? No, because yeah, the first initial portion is itself where the machine code went. So I think we last time like we couldn't set it up with like 0 from memory, or was that a different point? Okay, we don't have to do that now since it's just a register, but we have to keep in mind when we do the memory operations, that's kind of where we're doing it. So let's like move it to 1000 to begin with. The sprite pixel pointer. I guess we have to assign some memory to copy over initially as well. We could just like set up some like, pretend we're drawing like a 2x2 sprite and set things up that way. Yeah, I feel like we should. Load a 2x2 sprite into memory. So we want to be doing like the save word thing here. I want to do like save immediate. Can I do like save word immediate? Is that allowed? If not, we could try and make the pixels of this just like A, B, C, D, or something like this. So let's say we add, we put A in register 0, B in register 1, A1, C in that one, D in there, and now we can just say save the word that is what's the syntax again? I always forget. Yeah, we're storing the thing that's like the what's the value? Store the value that's in RS2 into the memory. So we want to be storing well, hang on. First of all, let's like clear out T0. Okay, and then we want to load the word which is the 4 bytes, which is what we care about. Load this into like memory position, whatever will be appropriate for the emulator. Maybe like 40. If it will allow that in the emulator, we'll see. At least this emulator will probably tell us that something's going wrong. And then we just want to repeat this, but with, wait, do I need semicolons? Yeah, and let's just increase each of these by 4. And then, wait, I'm not counting, 8, 9, 10, 11, 12. Then, this is fine for the moment. Let's just check this is working. No paste. Oh my goodness. Emacs, stop it. I said copy. Windows, what are you doing? I said copy all of this. Good. Okay. X0 used but not defined. That makes sense. No, it doesn't. Okay, it does. That was the line that it was complaining about. Okay, that compiled. So let's like step through it and make sure it's behaving. Wait, why can't I? Okay, it's exited with error code, but we expected that since we're not exiting it nicely. Okay, so we want to see in the memory the Z, like the A, B, and C, but I'm not seeing this. Okay, here it is. A, B, C, D. Great. Okay. So now we can check that pixel stuff is working to some degree of accuracy. To make this even easier to understand, let's change this a bit. Let's make this like AAA, BBB. Oh, there was an error here. And yeah, maybe this is fine. No, this happened. Yeah, this was like, I kind of remembered from last time. It doesn't like this stuff. So I want to say like load immediate, but are we even able to write that? Will this understand it? If I say load immediate, okay, it can do that. Good. Let's just clear this out. Load immediate. A0. Ooh, can we actually like fully do it now? Will this have a whinge? Let's see. 1, 2, 3. Okay, that was not the easiest solution. What? What does it mean, use but not define? Can it... Surely this is like... Oh, it may be because of the underscore. That is understandable. So you run it, it fails, it's expected, but in the memory, yeah, we see the things. Okay. So perhaps it just wants... It actually doesn't want underscores. Okay, yeah, this is what we'll do. Okay, we now have some pixel data. Memory to do stuff. So now we can actually call like appropriate stuff. So really, init pixel data. All of this is temporary. So now we can actually init init the call. So okay, so now we're calling it with the we also need like a position in memory to write this to. So we could just like write it at 80. The data's at 40, and now we need to add in full screen, please. We need to add in the the width, height, and the line increment. So the pixel pointer, the sprite pointer, the width, height, and next line increment. Okay. No, why did that happen? No, stop it. Windows, stop it. If it's a full screen, don't just make it a micro screen when I move it. Oh, this is so pathetic. This is so pathetic, Windows. Okay. Oh my goodness. Okay. Okay, so 80, 40, and then the width, in which case was just 2, 2, and then the next line increment, which for Oh, what should this be for us? I feel like in order to properly test this, we want the place that we're drawing it to like not be 2 by 2 either. So what if our canvas is like a 4 by 4? Canvas setup 4 by 4, and and what? And we like what do we have to work with? So if it's going to be a 4 by 4 canvas, then it's going to take up 16 lines here. So so we could make the canvas itself go from like 40 to 60, and then have the that's like zero it in with something boring like ones everywhere. So we're going to need like another testing function, init canvas. You can say like make like a 4 by 4 canvas in memory at 40 from spanning hex 40 to 80, and then let's actually have like this sprite memory here like at 90 instead. Okay, so then let's load an immediate, which is just like 1 1 1 1 1 1 1 1 into A0, and then just proceed to load it repeatedly. So let's load it at like hang on, we need to zero out that as well. Macro time. Try again. Copy, paste, first line. Okay, lots of copies, and then 4, 8, C, B, 8, 9, A, B, C, and then, okay, many of these copies were redundant. What I really want to do is paste that 4 times, and then replace that with 5. Six, no. Okay, this is. It's been too long since I've had to do any fancy Emacs commands. I'm clearly losing it. Delete 7 down. We'll get this correct. Delete 7. Okay. Yeah, there would have been, the Pro Emacs users could do that in 10 seconds instead of a minute, whatever. Oh no, I'm now like, these are wrong as well. But we can do another Emacs command. Define macro, paste a 0 in there, stop it. All of these become zeros, great. Okay, so now we should like flood. All of this was in the wrong location anyway. Flood a 4x4 canvas with this stuff, with all of the ones. And then now we can then load the pixel data into the memory at 90, I think it was. Why is this like not full screen? Then okay. This is just to test everything. So let's check that even this testing stuff is working. Label setup in the middle of an instruction. Is that because what? Are we just not allowed to have comments at all? Okay. Okay. Did its thing, and then when we check out memory, yeah, we see all of the ones in here as we wanted. And then, okay, I don't know why there's like a random B in there. Is it because we're not we're stomping over it with our like instruction code? Okay, we're gonna have to increase everything again. But this is fine. We can, since like all of these offsets are relative to t0, we can just set t0 to be something that won't get stomped. So if we make this like 1,000, stuff shouldn't get stomped. And then apparently like we couldn't have that here. Like seriously, why? What, how is the, oh, we have to use like pounds instead, okay. Fine, oh, but it doesn't like this one either. Oh, those should be load immediate. Yeah, we can do that. Load immediate into T0, 1,000. Okay. whatever, it should have got to there, fine. So if we go up to what I said, okay, 1,000. Why do we not see any values in here? Oh, it's not compiling. Yeah, well, it's not running because it hasn't compiled. Seriously. Okay, that's what we wanted. Then, okay, now we've got all of our ones. Great. Bunch of zeros and then the canvas. Okay, good. Okay. Just to make things like easier slightly, given all the fact that all of these things have been offset by, I kind of want them just to start at 1,000 instead. And likewise, hopefully the simulator can do this. It may not be able to. Let's see. Yeah, I knew it. That is okay. So let's see. Like the easiest, there's an easy way. There's an easy way to deal with all of this. Okay, yeah. You have to know when to give up. Okay. And then let's just have this at like 50 instead. Okay, so now it is at a sensible location. All of the canvas there, a bunch of zeros, the data we want to draw. Okay, now we can actually get into the task of writing the code for this, and we'll have something decent to test it with. Okay. So yeah, so what do we want to, how do we want to call this? So yeah, so now we're saying call this at we want to be drawing this at, so we don't exactly want to be drawing this at 1,000. We want to be drawing this at like the second row of the canvas at the second pixel. So this will be every row in this 4x4 canvas is just 16 bytes. So the second row will be there. And then the location of the sprite pointer was by construction 50 as above, and then it is 2 by 2 by 2. And right, the number of bytes that we're hopping every line by is now it's just, yeah, the frame width times the sprite width multiplied by 2. So it should just be 4, right? No, that can't be correct. It should just be +1. It should be like +3. Oh no, it's +2 because we're adding in like the extra 1. That's right. Yeah. Okay, so now we want to now we want to initialize everything with those values. So load immediate 1014 into A0 into A1, load 1050, load 2 into A2, load 2 into A3, load 2 into A4. Okay, and now we can actually get into the like proper stuff. So yeah, we should declare what our temporary variables are going to be in this case. Remembering from last time that we did this, that the calling convention is slightly different in this arena. So we can use some of these register values, but not all of them. In particular, it was like we couldn't use T. Let's just check out in this arena again what this was. Oh, and like very handily, it's kind of already been loaded and here before. No, we don't want to go into the Sokoban. We want to go back into the RISC-V. And we wanted to check out in read-only mode what we did for the disk. Okay, so this was what? Okay, we can use T1, T0, and T2, but we have to jump up to S3, S4, and S5. Okay. Thank you, Windows, for once again shrinking things without asking. So yeah, those are fine, and then we want S3, S4, and S5. Okay, and then let's like quit out of this and go back to what we want to translate. Okay, so yeah, what values are going where in this calculation? What's changing? So the width and the height and the line jump are clearly never changing. So the only variables we want to keep track of are the pixel pointer, the sprite pointer, and the well, that's kind of well, we have an I, a J. What's changing? I is changing, J is changing, frame pointer is changing, and the sprite pointer is changing. But that's kind of it. So let's assign like T0 and T1 to be I, J, and I kind of want like I and J to just be referred to with the T's to kind of make it slightly easier. And then we can use S3 and S4 for the frame pointer, frame pixel pointer, and the sprite pixel pointer. So what's the time? Okay. I think we'll have time to like do this today. So what's happening? Well, we need to init all of these things first. So I is remaining at 0, so we want to say I feel like the load immediate like instruction, I'm not sure how like Sam does in the compiler, but if there's like an easy way to, there's like a single instruction way to do it, we should be doing that instead. So we want to say set I to be 0, so within T0 add 0 to itself. Likewise, we're not like we don't want to push up I just yet, but we're going to have like the rest of this stuff, and then the prolata statement. So T0, and we're just adding 1 to it, and then we're increasing the frame pixel pointer by the line. So where are we storing the frame pixel pointer? S3. So we're adding, oh, it's not add immediate anymore. It is add A4 to this thing. See, yeah, so this is just frame pixel pointer plus equals the next line increment. Okay, and then we want to like jump in the loop back. How do we do the jumping syntax again? This thing. So how did I refer to these over here? Okay, so I had a init, and then I had like loop I and other stuff. So we'll do that, and then loop I, and then I loop. And down here we want to say one of like the branching things. Then we're looping if what? If, well, I here is, we loop if and only if I is less than the height. So loop if I is less than the height. The height is going to get passed in as the fourth parameter, so it will be in A3. And so we want to do a comparison between T0 and A3. And what exactly do we want again? We have like half of the options we want in RISC-V. So we want to do, where's the branch? There's the branch. We want to do, what do we have? branch less than or branch greater than or equal to. So yeah, so we want to branch to it if I is less, it's less than or equal to, not greater than. So let's see, the equivalent of saying I is strictly less than the height is saying the height is greater than what's this thing again? What do we want to do? We want to say like the height is greater than or equal to. This stuff is always so annoying. It's like one line of logic, but it's so bug ridden. So express this using greater than or equal to in some way. So yeah, what do we want? We want like, see if our only options are greater than or equal to or strictly less than. These are the only two, right? Yeah. So jump when I don't want to have something where we like jump to some other instruction that says like finish it, and then otherwise it like goes to another loop that says like jump directly. Like that's crude. It should be possible to like reformulate this so it's jumped in just a single instruction. Loop if what? If the we can't say the height is greater than or equal to I, because that would then loop when I is equal to the height. You can't say like the height is less than I. Just something with like I is greater than. Well, how do we translate this? In some way that's not like offensive. I feel like there's only 4 possible. There's like 8 possibilities in total. So what are the possibilities? It's just I is greater than the height, no, greater than or equal to the height. The height is greater than or equal to I. Wait, none of these are like correct, right? I'm just being totally dumb. I don't know what just happened. We just branch that if I is less than it. It's fine. Everything's fine. My goodness. The trauma of having to like allocate this meant I thought I had to do it, something when I actually didn't. Okay, it's just that. We just say if R1 is strictly less than it, jump, otherwise it's fine. So branch if, wait, that's not, what was the syntax? Branch if less than, okay. So I is being held in T0. We're saying if I is less than the height, jump to loop I. Great. Okay. Okay, so then that does like the prolata statement stuff. And so, yeah, loop if I, continue I loop if I is less than the height. Okay. Yeah, so in terms of the knitting stuff, we want to copy yeah, we want to copy S, we want to copy A0 to S3, and we want to copy A1 to S4. Okay, now we've got our I loop. So within this loop, what are we doing? We are first setting up the J loop. So I guess we can just say add, we'll just make J equal to 0. And then we've got our loop J. And here's the time where stuff actually gets done. So we want to say, well, we simply assign memory to things, and then we increase all of the counters. So I don't think memory to memory operations in RISC-V are possible. I'm kind of forgetting. Oh, we're gonna have to do some like load instructions instead of just save instructions. It's been a while since we've done this. How do we do this? Where's like the memory? Data transfer. Okay, so it's just, it's like L, no, this is what I remember. It was like, there's like this like LWU and like LHU, like all of this like crappy like upper word or something, whatever. So we just want, okay, we just want the simple load word from, with the same kind of syntax, like load, yeah, load word into that register from that when it's been offset. LW. So load word into the place, and then let's use like T0 as like temporary, like temporary pixel. So we want to, let's 20. So we're saying into T0. Oh, okay, we have to do the memory address stuff now. Some of these registers will have to hold memory stuff, which is fine. what's the syntax again? This thing. So with no offset at all, load entity to the memory location that the sprite pointer is at, which is S4. Then we want to load this into wherever the frame pointer is at. So now store whatever's there into T5. Frame pixel pointer is equal to T dereferenced is equal to T2. And now we need to do like the looping conditions. So now we compare. We want to branch if j is less than the width. That is, if T1 is less than the width, which is going to be stored in A2. In which case, well, hang on. Before we do any of that, we need to increase the things. We need to add 1 to j. We then need to increase the frame pointer and the pixel pointer by 4. Then we have to do the branch operation. All of these are not aligned super nicely. Okay, and then why are these lines not commented? Let's do these. S3 is equal to yeah, increase j by 1. Here we're doing the pixel pointer plus 4 frame sprite pixel pointer by 4. Then what's this? Yeah, loop if we'll continue j loop if j is less than the width. Okay, but otherwise that kind of feels like the end. But what's this like loop j here saying? Maybe that's like loop j end, in which case I feel like here I should have loop j end, and then here can be loop I end, which bizarrely I didn't add it in there, but okay. And then I think that's kind of it. Yeah. Okay, let's try running this and seeing what the result is. Okay, it really doesn't like a lot of these. Why? Okay, that's clearly that's like a single mistake. Oh, it's because of these bloody comments. Okay. Let's replace all instances of / with that. Replace all with that. This here should be for setting t0 to be 0. It should just say like add. It could even be simpler. You can just simply say add. Zero it out that way. Oh, why are we not zeroing out? We are zeroing out J in that way. Good. Okay. Okay. No underlines. Great. That compiled. Oh, why are we getting these invalid instructions? That is not good. At all. Oh, it's because no, why? Because we're like writing all of those to memory. No. Yeah, so stuff. I guess like the program must have like exit, right? No, wait, let's step through this. This thing is looping with how. Oh, this was like, yeah, this was it like the scrolling in this is really annoying, and so it like doesn't. You can't like easily see. It's like currently looping now. Not that you would know that. Oh, so annoying. Can we actually see it like start to loop properly here? Okay, disastrous. Okay, let's just step through this and kind of see what's going on. So all of this stuff is just like boring setup, whatever. Okay, but now we get to the proper. You almost get to the proper stuff. Okay, I think we're nearly here. It's like load intermediate stuff. Okay. So yeah, what's like our first actual instruction? Yeah, add t0 x0 x0. So so yeah, x0 is, wait, why are we adding 20 now? Where in here are we adding 20? Is this like another load intermediate thing? Oh, okay, okay. The comments are being transferred over, great. We're still in setup stuff. Okay. Here we are. So yeah, I is being set to 0. Yeah, we're now saying like the add I here is a bit confusing, actually. I want to change that. I think it would be clear if both of these are just adds, and in every case we're just adding x0. Okay, and then with this stop scrolling down so I can see what's coming next. It's so ridiculous. Yeah, J is set to 0. Okay, and then we do our first write 2 steps down. So where are the registers here? This actually makes me just want to write my own program like in Zig or even later on in Brevis just to do this. It's like this behavior, this scrolling behavior is not acceptable. Okay, so we're saying why is S5 empty? Why are we using S4 and S5 instead of S3 and S2? That is not correct. Like there shouldn't be any references of S5 in here at all. Okay, I think that explains the bug. Or at least one of them. Okay, and then what does it look like in memory? Aha, it looks like we have drawn the pixels here. Great. So yeah, the first line is like empty, next line is empty, and then I spoke too soon. I'm not seeing any of. Why is there like a 0B here? That's so weird. Okay, let's step through this thing again. Okay. Let's just make sure this is first of all looping as we expect. So do we expect it to loop back there? So yeah, it should immediately be looping up to the load W, which I think it did. Not that you can tell because of the freaking way this is scrolling. So just B4 is what we want to land on. Okay, I have to start again. So we want to count how many times B4 happens. So, okay, one lot of B4 has already happened, and we want to jump back to it, which we have. Then we want to kind of pass through it this time and jump back to the I loop instead. But for the I loop, we want to jump to like the line above it, which maybe we did. Not that we can observe it because of the scrolling. And then jump to B4 again. Okay, now it's jump to B0. Jump to B4 again. Oh, and then it's jump to B4 yet again. And then it should exit this time. Oh, but then it jumped to B0 again. So why is this like... It's like drawing this in some like weird 4x4 way. Okay, something's clearly wrong. Let's figure out why more than 2 loops is happening for J to begin with. So when we get when we get down to the J, this is being stored in T1, which is where scrolling. This should be J. Okay. So yeah, it is already 0 as expected. Yeah, it gets set to 0. Yeah, we've loaded in, why is this loading in the canvas instead of the sprite? Which is why it's good to spend effort setting up the debug example carefully, because that itself gives you lots of information. Oh, okay. This was again like the S3, S5 issue. Yeah, the sprite pointer is S4, but our frame pointer is S3. Okay, frame pointer S3, sprite pointer S4. S3 is the frame pointer. Okay. Okay, I think that fixes at least that issue, but it doesn't explain like the looping behavior. Okay. So now in memory, yeah, there's a bunch of ones which is expected, but now we're seeing all of these weird symbols. Something's really off. And then stuff's getting stomped everywhere. Okay. We are far off from fixing all the bugs, but we're getting there. Okay, so now let's go back to the looping thing again. T1. So yeah, so we want to be tracking J. So yeah, J set to 0. Then yes, like thing is loaded, thing is saved. J increases by 1. Frame pointer gets pushed up. I mean frame you know what I mean by frequent sprite. We loop. Another thing gets loaded. Another thing gets loaded. J gets pushed up by 1. So now it's 2. So now it should, when we get to the branch, we should fail this. Oh, why is this called branch if greater than? Come on, it's meant to be branch if less than. Wait, what? This says BLE. Why does it say BGE here? Wait, now I'm confused. What do these two columns even mean? Like, okay, oh, this is the instruction I said, and this is what got put in there. Okay. Yeah, I suppose that's fine. But, so yeah, so T1 is what we wanted, and then an A2 is meant to have 2 as well, yeah. So then we branch up to here, but that's not correct. Did we get the order of these around the wrong way? Oh, I'll be so freaking pissed if I did. I feel like that has... No, but both of them are 2, so... What's going on? Like, but it should pass through to the next instruction. Okay, which it did that time. But why? That's 3, and A2 is... Unless it's like interpreting this as like branch if less than or equal to, but it's like not. Oh, is that what the BLE means? It's not like... Oh my goodness. Freaking syntax. It's BLT, not BLE. Oh my goodness. Okay. Try again. Okay. Run. Do this. Let's. Things are still not as they're behaving. We see all of the base pixels here, but then random stuff floating in the middle. But yeah, but that was some progress. That at least explains the weird branching behavior. Okay, let's continue to go through this line by line. Okay. So now, where's the registers? T2. Okay, so now, just highlight it, please. So yeah, it's 0, it's 1, and now Yeah, branch if less than, it jumps back to here. It's 2, so now it should fail. Good, it has. The I gets pushed up by 1, which we expect to see in T0, indeed. This stuff gets added, and then it should branch because it's not yet 2, which should be in A3. Yeah. So we go back up to there. We should reset J to be 0, which it has. Branch back up, another load and write, and then the next branch should fall through. The next branch should also fall through. Great. Okay. So it's doing the correct number of iterations, it's just that the memory is getting written in some weird locations. That may be due to the setup of everything, so let's keep an eye on that when we do it. Okay, so in terms of where everything is going, what we want in A's, let's just get to the actual setup code. Okay, so we want in A0 should be the frame pointer, which is meant to be the blank canvas of the ones everywhere, which was at 1,000. Always A0 here. That's not 1,000, it's 1,014. Which is fine since, right, 14 was the offset. This is the pixel we actually want to start writing this stuff on. This one. And then it's still going to be there, right? Yeah. So yeah, why is it 0B now all of a sudden? This is so odd. So this stuff we could really, okay, let's track this down. So we're saying, what's S4? This is not correct. S4 is not meant to be 2. This explains the weird data, where the bytes that were getting written were the machine code for this exact program. So S4 hasn't yet got written correctly. That means we haven't set it up, so why did we not set that up? Because we're using A2 here instead of A1. And so the 2 there would make sense because the width was 2. Okay. Let's try again. Run it. Yeah, but great. This is what we want to see. We want to see all of these pixels written in here. There's some weird gaps, so there's some offset that's not correct. I guess this was like the line offset. Presumably. Why did things get bumped up weirdly? But otherwise, this is kind of what we wanted. Was very close. So the only issue now is where are these coming from? Why did the pointer get advanced by like 2 instead of 4? Or rather by 6 instead of 4? This is good, we're so close. After this we'll be able to copy it over to the Serenum and then draw textures quickly. And then once we have our textures drawing quickly, we can start making, well, we can get textures into the Sokoban, but then we can also work on the way quicker first shippable Serenum game that I'll make. That won't be, the Sokoban's going to take like, it's going to ship next year, I realized. It's a long endeavor. The other one in my mind is super simple, but not completely trivial. Yeah, so what's causing like the weird offset? So it must be this next frame pointer line. Why did I get this wrong by saying it's a 2? Oh, it's 2 times the number of bytes, which is 4. Okay, so okay, so in this case, but first of all, why, if this is the error, what would we is what the like? Does what we have before match what we're seeing? Okay, so we would expect in the part of the loop where we bump up by the next line pointer, if A4, right? Well, what we want to see over here is not just like 2 gaps, but literally like 2 entire lines of 1-1s. Okay. Do this again. Infinite loop alert because I didn't return correctly or whatever. Okay. Let's avoid including return at the bottom. Stalming mechanism. Okay. Run. Okay, great. Yeah, go all the ones. A. We have AB. Gap. Oh no, it still hasn't done it. I guess that's because we didn't actually like add it into the assembly properly. Yeah, that's meant to be. It's meant to be our 8. Okay. Great, and now we should be good to take it to this arena. This is what we want. So yeah, in this like sprite, it's like default. Don't know why there's a 0B here though. This is still a bit concerning. Well, now I'm really concerned. Why are there not like 11s in everything? Like, why on earth is that 0B instead of 11? I feel like maybe this is something due to the emulator, but like in either case, I guess we could actually just like step through it. Yeah, 1, 1, 1, 1, 1. All of those lines are getting zeroed out. And then we're filling in the stuff above with where did we send it to again? $150. 1050. Okay, so that stuff has got loaded. Okay, and then okay, yeah, stuff's like that's fine. The zeros haven't appeared yet. Yeah, what's this? Like, why is... Oh, so it's actually... Okay, it must be some bug with this. Because I don't see any of the 0Bs appearing here again. Okay, whatever. Great. Okay, let's move our code to this arena. So let's cut power to this arena. Get rid of this. And we can like set our SD card. The USB ports are taken. I'm gonna have to add it to the back of the machine. I know, if I like change up the keyboard cable. Okay. Great. And so now back in. Okay. Let's get out of Emacs. But not saving. No, we don't want to save that. And I'm gonna have to just answer a message. Okay. So yeah, let's so let's see, the draw this is the one we wanted. Right. Wow, like isn't Microsoft wonderful? Yeah, this is what we want. So yeah, if we move this into the RISC-V drawing experiment, yeah, we should be good to get this on the Serena now. Okay. Let's get this working again. Okay. Okay, back to the non-power hungry keyboard. My usual keyboard is too much for this Serena. It will refuse to connect with it because its power draw is too much. So let's open up the draw sprite assembly. But yeah, so it is there. Oh, is this the resolution we want? Oh, I don't know. Here. Okay, I think this is what we want. Great, okay, so now we can basically forget everything in the setup except this stuff. Copy. And let's open another window here. Let's edit our texture assembly. Now we can paste this in. However, we're going to have to annotate this in the actual, using the actual language. Oh, hang on. When we're doing it this way, it requires like different syntax. It was, let's see, from memory it was not, it was like quotation marks instead of like the brackets. And I think that was it, maybe? Okay. Okay. Let's test it and see how it holds up. Let's open another window. RISC-V. Now we want to do, I'm going to compile this. So yeah, take texture LVC to texture ASM. Oh, that's right. I have to use like the assembly like procedure keyword. Let's remind ourselves how that part worked. Let's quit out of this and open up the disk. That's right. Procedure compilator is what we wanted. Did I not paste that? Okay. Compilata. Okay. Let's try and compile this again. Didn't like something in here. We forgot to update the hashes. Of course. Let's quit out of this. Okay, save this. Try it again. Huh? It doesn't understand / what? This is very confusing. How on earth did we do comments in this version? Oh, did I just remove all the comments? That doesn't feel particularly wise at all. How you meant to know what this is doing? I might send an email to Sam about this. Yeah, this is not. I feel like assembly of all things should be annotated. Oh no! What are we doing? Quit without saving, please. A script or a texture to. Yes, no, that wasn't without. Okay. Okay, let's try this. No, again. Oh, this is painful. This is so painful. It paused. Yes. Okay. Now the question is, will it actually render as we said it should? Let us see. I always feel nervous when it's something like this. Okay. Texture ASM. Hasn't crashed. Aha! And it's rendered. Fantastic. Hoorah. This is really good. So, so now I'm kind of curious in just seeing how quick this is. So what happens now if we animate a texture in some way? Now I want to put one of these on let's animate some of these. It's gonna be fun. Okay, but this is great. Hurrah. Hurrah. Okay, and then we could have some fun. We now have almost like everything we need to make a really basic game or like a tech demo. And so we can do a fun example with this texture. So let's try and get this texture moving, and then we can modify it to be something that we would like expect to move, and then we can record like a tech demo for the Discord. So this is really good. So now it's working. But we can definitely get rid of all of this. It's not needed. Yeah, what's something moving stuff in a loop is difficult, simply because there's no floats yet. But we could just take some of the code from our like previous one, maybe not. What if we just move something in like a couple of things in lines back and forth? Like that itself could be enough. So in that case, we want to just like animate stuff with like the X pos and the Y pos. So we could say in this loop, what if we said X pos is equal to, we can start off at like 100, and then we'll make the Y pos equal to like 200, and then every frame we can update this in some way. Update the position, the sprite position. So why don't we just increase this by a bit every frame? Like we could just say C X pos, if the X pos is less than 100, then if X pos is less than 100, make it let's just like move things in a line that kind of jump from like the right of the screen to the left. So we can say if the X pos is, and we need to add in safety areas, but let's say it's like 700. Then simply set the X pos to be 100. And then similarly, if really it should be X pos plus equals like 5, and like the Y pos, like maybe we don't actually have to do anything with the Y pos for this demo. I think it will be fine as is. Let's increase it by 5, and then yeah, let's or we could even like have these going at like different rates in some way. But let's see how fast it is with one to begin with. Put this on the Y-pause and put this on the X-pause. Okay. And then yeah, let's initial sprite values. Let's compile this. Ooh, if we're not actually like resetting the oh, we forgot to semicolon it. We should be blanking out the screen with a rectangle there, because currently it's commented, but let's do that. Assuming we still have like dark gray here, which we do. Looks like it's gonna compile. Aha! The texture is moving. And this frame rate seems like high enough. I can still see some like jittering, but that is moving. I now wonder how, like, what it will be like if we increase the resolution. Take a bit longer to load. Maybe it will be similar. So let's instead do, let's have like 2 of them going as well. So we'll make it up to 3 here, and we'll make this like X-pause 1 and like X-pause 2, and then maybe we start this one at 400 and 200 and 400. And now we want to say reset it if it's like that. And then in the X-pause 2 case, let's have these going at different speeds as well. X-pause 2 plus equals, perhaps this one is a bit slower. Okay. Let's compile this, see how fast it runs. Then we can, what does it mean? I don't know of anything called X-pause 2. Did I not just define that? In either case, we need to actually draw 2 of them, I think. X-pause 1, Y-pause 1. X-pause 2, Y-pause 2. Okay. Okay, the frame rate has plummeted massively. But I think that's because every time we're drawing, like, we're having to like clear the entire background, and so a huge like vector, even though it is a vector, a huge vector computation is happening in the background. Let's clear. Let's like not wipe the background in that way and see how fast it is instead. Okay, so now we'll save that, compile it again. But yeah, this is good to know that even like simply drawing 2 sprites on a screen, if you're like wiping the entire screen every time, the frame rate is busted like that. Whoa, that's so smooth. That is incredibly smooth. That looks really cool. Okay. So this is good. So let's now yeah, let's replace these sprites with something that's like more yeah, we'll replace this with some extra things. Let's also like move them. Move them in a different way. Alternatively, we don't actually have to. Let's continue to like wipe the screen in the background, but we can do like a really like a super easy optimization. Instead of like wiping the entire canvas, we can simply wipe the area of the canvas over where the previous texture was. So given that we already know like the position of this thing, we could just say draw a rectangle at okay, let's first of all simplify this by going back to animating over only a single one. So let's say we do let's go back to xpos and ypos for simplicity. We'll put these at different. We'll make these jump. We want it to loop. We want that one to loop whenever that's happening. The X to loop when it gets near the end. And then for the Y pause, we'll loop it whenever it's like at 500. So yeah, so then in terms of like the drawing, instead of drawing the background color, we should say like clear. like we do want to draw the background color like once for the entire thing, and then, but only ever once. This is a bit annoying. Were it not for the fact that, see, it's just like the noob start. Oh wait, why are we calling like noob start frame every time? That's like, that's really silly. I don't think that's meant to happen. Or is it? Oh, I'm forgetting. Maybe we are. Maybe we are meant to do that. In either case, we can do like an initial thing. So let's like start the frame, draw the background. Draw a blank frame. A noob frame, frame begin. Draw the entire background like that. Then just end it. Okay, and now we can draw over the sprite. So here we want to do the X pos minus some kind of buffer. So that's like subtracted by 10. And the Y pos, subtract that by say 10. And then in terms of the overall width, we really just want to add in the the roof sprite dot, oh, if it's even going to allow it without casting it. The roof sprite dot well, we know what this is. We can just if it's 25, we can just offset this by like 35 is technically all we need. But let's just add in like 50, because whatever. Save that, and then we can do a bit better. We can just make this. Do that, and then render it. Okay. Okay, let's try and compile this. And we can have super smooth sprite animating on the Serenum. In the knowledge that, you know, Framework Laptop was talking about their like newest RISC-V motherboard, but they were like, you have to be really careful though, like it's super slow at the moment, like it takes like minutes to boot up or something, and I'm just like, but the Serenum can already play games. Okay. Well, not expecting this much flashing. This is a bit much. There's also something wrong with the background colors being out of sync. And of course the bug where stuff is getting shifted over. But okay. It is aside from like the blinking, it is smooth. So let's fix that. I think we can quit out of this. So like incorrect colors are being used, where like one of them was, I thought in each of these cases we're using dark gray though, so I don't know why. Why is the background getting like a different color when we're using dark gray in every case? Why don't we just make everything black? And then, in order to stop the incorrect drawing, we can do this. But we should start drawing this before we attempt to go over it. Okay, let's try this one. Okay, flickering still happening. Stuff is still not getting drawn over correctly, but in the very least, it's moving really smoothly. Yeah, the flickering sucks, but the flickering will, once we like paste over it, it won't happen again. So let's fix that. So yeah, so what's happening? So things are like getting stuck on the corner and then not getting pasted over with. So, so why? We draw over the previous sprite, and then if we update it and we send it to like a different corner, and then we like render it. Why isn't it? No, why is this getting stuck? So so we're saying the previous, like, say in the previous frame, it's at the bottom of the image. We then like cover over that, and then we update these positions. Then we draw it at the top. And then we end the frame. Oh, is it because of like, it's because of like partial resetting? Like if one of them changes, like the xpos changes, but then, that wouldn't. Yeah, I'm really confused by this. Um, so okay, let's say it's like, it's on the frame before it's going to warp around. Then, it's been updated, but it hasn't yet warped. The sprite is drawn. Okay, then on the next frame, we paste over it. It updates, so then it gets like warped, and then it gets drawn there. Yeah, I don't see like where's the bug. I feel like there's a really simple thing saying here I'm missing, but I'm not seeing it. I think it's because it's being drawn somewhere, and then no. Like, yeah, I can't see. I'm so confused. Like, why is this flawed? Like, we draw it with known x pos, y pos positions. It loops, and then in that meantime, when it loops, the values have not changed. And then we then like wipe over it here, and then we change the values. Like, why? Is there some like weird race condition or something going on? More spam. More spam accounts. Where's like the do it. Where's the? Where is it? Okay. Yeah, so I'm okay. Like what? Let's like consider what behavior could like what's not happening in order for us to see this behavior. So the sprite is getting drawn, and then things get updated so that the rectangle never has a chance to actually paste over it. So that means that like the rectangle drawing function is either completely skipped, which I don't think is feasible, or the like locations for it get adjusted before it has a chance to do that. So I could see that perhaps like after we draw the sprite, and it's like the sprite has been drawn in like on like the far right of the screen, then we do like we then issue the call draw a rectangle over this, but then in the meantime like this is like somehow like updated in the background, so like before like the thing has a chance to even like paste over it, it's being updated to like the other position. Maybe this was very unsatisfying. Actually, maybe the way to avoid this is to only update all of this information after. I was gonna say after things have gotten drawn, but then that's like, kind of like what's the point of that then? Okay, so let's actually like let's do the. We're gonna have to do some like calculation here. So draw over the previous sprite. Which is, yeah, coordinates like that, totally fine. Then draw it and then update it. Let's see if this solves the problem. No, it's still happening again. This is so annoying. I might have to email Sam about this. Yeah, like I'm also concerned, like why is like the jittering happening? Why is this going back and forth? Yeah, what's the way around this? I think a way around this is to stop it warping. Stop it warping. We'll just make it move smoothly back and forth. And that's all that's needed. That's one of the constraints of the system that we're dealing with. So yeah, no warping happening. So let's have like a velocity instead. Let's just cut that completely. Let's just say like velocity, v x velocity. Let's make the velocity initially 5. And then if the x position is greater than that, well, first of all, we're gonna change the x position with the velocity, and then if the x position is greater than 700, the x velocity is equal to negative of the x. Will this cause any bugs? Why is it? I feel like the names are changing. Xpos, xval. If the xpos is greater than 100, negate it so that the next time it will be better. Okay. No, I feel like that's going to fail to compile since we didn't add in like a concrete y value position. When we're rendering the sprite, let's render this at like 300. Okay. No, I forgot something again. I think we won't bother updating the sprite. We're just gonna like post this to Discord and move on. I think we crashed it, and we absolutely did. And stuff was getting like overlapped as well, which was not what was meant to happen. Like the new rectangles weren't getting drawn correctly. Like we can't possibly be like are we getting the arguments of the new rectangle around the wrong way? In either case, let's just like fix this. If xpos is less than 100, xval is equal to negative. Let's just have like an or statement. Both of these are the same. If xpos is less than 100, or xpos is greater than that, flip the direction. Yeah, so now I'm like really concerned about the new rectangle arguments, but I thought it was like x, y, then the width, so don't know why it seemed to be drawing incorrectly the last time. How long have we been streaming for anyway? Nearly 3.5 hours. Okay. Not what we wanted. Why is the direction not getting reversed? Something's very wrong. I'm going to turn the lights on, it's a bit dark in here. I feel like there's actually a really easy solution to this for which things may still be performant. And that's just to like draw an entire a big rectangle, but just like a strip. So what if what if we instead draw the rectangle from like 0, 300, but now the width is like the frame dot the width, and then we just make it 25 high. So we zero it out every single time. Then over here, we can try this, and furthermore, we can now actually just make it loop. So we could say, gone are the days of the x velocity. It increases by 5 each time, and if it's greater than 700, make it equal to 100. Yeah, so this like new rectangle is making me nervous about what the correct arguments are. Let's like check out. Let's check out the Sokoban again. Where it's like the render character procedure. No, yeah, it is position x pos, y pos, width. So it was correct in that. I guess we just have to cast it. Okay, this better work. Product. Okay. It's moving. Okay. I kind of want this to be bigger though. Now I do like want to get an actual like a better texture in. Okay, but this is, we can like, I think we can leave. This is working, so let's like save a backup of this, I think. So yeah, let's like copy. Actually, let's just make a backup of this. Get rid of the Serenium power, and okay, so we can do the backup like slightly later. Get it into the system. And now let's like find some public domain texture that we can animate and show the Discord. So if we go to like Wiki media comments, maybe we could do like, I don't know, like animal icon, like a kangaroo or something. Oh, some of these look cool, but they must have no restrictions on them. Like that would kind of work, I guess. Like we want something that when we like compress it down to something that's like 50 by 50, it will be okay. It will survive. It will survive some kind of compression. I guess that itself is fine. What if we had like computer icon, I don't know. Kind of. Why don't we have like a ship? Is a transport icon. Like I want something with colors, but all of these are like what's like a mammal icon? Like some of these could survive. Like the black outline is a bit incorrect for the background. Maybe if it's like What if it's just like some math icon instead? This could be easier. Or if these are public domain, it could just be something simple. This looks fine. This is just like, this is enough. Oh, let's do like an astronomy icon. If it's like a sun or the moon. If it's like something like maybe the moon is just what I want. Or maybe just like a graphic of the moon itself. Oh, this is like sufficiently colorful. This could be interesting. I think this would look fine against like a black background, maybe. It certainly shows lots of colors. This is the opposite of this arena. That's bad. Even a like rocket ship like this could be fun. I swear I've seen this in like some like Pygame tutorial. Oh, this itself looks pretty decent. I think that will compress fine. Okay, let's do this. This is like, it's obviously the moon. Oh no, but we want the background to be transparent. Oh, I guess it is. I think. Now I'm worried that like. Oh, there's like a shadow in the background that we don't want. Actually, it may be fine. Yeah, if we're downloading this as a PNG, it should be transparent in the background, I think. We'll see. We will see. Where's this arena? Okay. And now let's open it with. For now. Windows, when I press tab, once I've written doc, you know it's documents, open it. You don't have to be so bad all the time. It's possible to put out decent. Oh, well, we all know why. Microsoft is so slow. So yeah, if we go into the Serenum, Sokoban, and the sprites, and then we do the Zig image viewer moon.png. Why has it not loaded? Okay. Okay. That, yeah, it seems that the background is not, yeah, this will look great. This will look great in the demo. Let's convert this to magic k moon.png moon.qi. Zig image viewer moon.qi. No, why is there that the shitty background on it? It looks like trash. That's total trash. just go back. Let's just get rid of icon and just type in like a moon. It's fine if the background is black. No one cares. This is... we want like a full moon. Okay, this one of these look dope. That one's like that one. This one has too much color. Yeah, we can easily. We'll just crop this. This will be the easiest. It's like download that version. Yeah, say that they're fine. So if we do like paint, I'm not want. Why can I not launch paint as a command line activity? Where's like the cropping button? Do I have to use GIMP? I think I do. Yeah, we're gonna have to, if we're like resizing this to something precise anyway, we need to use GIMP. Yeah, hello. Open as layers. Serenum. This one. Okay, now we're getting somewhere. Let's crop this. And whatever we crop it, we want it to be a square. So I guess if we make this like 180 by 180, and then move it like here, that basically looks centered to me. 172. Actually, let's make this 175 so that it's like an easy multiple of 25. Okay. Wow, thank you GIMP for just like rendering this off the actual screen. Who knows what it's called, but that's what it is. Image was like crop to content. Okay. Now let's shrink this down. Image, and so it's until it's like 50 by 50. No. If this image is 175 by 175, why is it getting scaled to 51 by 50? It's ridiculous. Totally ridiculous. This is not acceptable. Okay. That is the moon. Let's export it as a PNG. Export as. Who knows what it's called? It is being exported as a PNG. Great if I could actually control that, but apparently not. What is it even called? Okay, it must be like full moon by, this must be it here. Okay. Let's like copy over moon.png and now do magic k moon.png moon.qi. Let's just make sure the qi file is fine. It's distorted, but That's only because the software itself is not correct. It's good. So now let's do like the Brevis ingest. So copy that to there. Let's open the, I think it was called roof.qi. It really should be, let's like remove all of the clutter first. Is it QI to raw bytes? Run Emacs QI to raw bytes. That moon.qi, file name moon.data. That's fine. Okay, zig run qi to raw bytes.zig. That looks kind of correct. I see lots of blacks in here, lots of moons. Yeah, I'm sure this is fine. So this is called, what did this output it to? Moon.data, presumably. Yeah. Yeah, it should be fine. So now let's copy moon.data onto the Serena. Let's just close stuff. Get the Serenum turned on again. And we can render our moon and call it a day. Okay. Wait for this to boot up. Oh, we're meant to make like a backup. I guess we'll do that after this. Okay. Let's see. Go to the RISC-V. To the codecs. The moon.data is there. Great. So now we can say, let's make a file called like moon.lbc. Let's file copy the texture assembly over to the moon.lbc. Once we give it permissions to do that. Now let's open the moon.lbc. We want to import the moon.data as the data. And then we can say like moon sprite. Oh, we're not. We forgot to open this in read-only mode. I mean in edit mode. moon.data, moon sprite data, save. Oh shoot, what did we even like, what's even the dimensions of this? I've already forgotten. Did we save it as like, it was meant to be 25, but did we actually save it as that? I mean, it was meant to be 50 by 50, something slightly larger. Serenum, Sokoban, sprites. What if we go to like, what is the details? It is 50 by 50. Okay. Oh shoot! In our zig export, did we would the zig export just have cropped a really small amount of it? Let's like, in either case, we'll, no, I'm like, I don't know. Before we even start doing anything of it, before we do any more in this arena, let's just find out. Cure I to raw bytes. Oh yeah, we set the limit to be 25. Not good. So the limit's now 50. And this should be limit. Okay, so yeah, go across the pixels in this image. Shoot, yeah, we're gonna have to run this again. Yeah, zig run cure I to raw bytes. Okay, that's better. We kind of expect the final line of the image to just be a bunch of black pixels, which is what this now shows. Okay, let's get that back on here. Okay. So yeah, this was currently there was previously 3 kilobytes, and now it's like 10, which is more than we'd expect. Replace the file in the destination. Okay. Okay. No. RISC-V, codecs, script.m, moon.lbc. So yeah, moon data, moon sprite data. Moon sprite, moon sprite, moon sprite, moon sprite. Let's write data, save. I guess since it's already black anyway, this entire thing can probably be. I'll probably forget about that. And then the draw sprite here, we want the moon sprite. And in terms of the size, I guess we want this to now be 50. And when we're setting the width of everything, it's now 50 by 50. Okay, and I think that's all we need to do. So let's try compiling this. Let's go into the RISC-V. Let's go into the productor. Let's make a file called like moon.pb. Now let's compile it. So look in codecs, look for moon.lbc, and we're compiling it to productor moon.pb. Okay, it's going to compile and hopefully run without any weird 25, 50 errors somewhere. But let's see. Let's see. Aha! Fantastic. Incredible. It is doing the thing. So this is like slightly too fast for my liking. So let's like reduce the speed, and also let's make sure it doesn't like wrap all the way at 700, but it can truly go across the screen. Okay, but this is great. This is fantastic. So so the speed is too high at 5, so let's make it 3. I think even like 2 could be better, and because it is updating really quickly. And then instead of 700, if we're doing like 440 by 1080, we could just do like 1300 maybe. But yeah. No, we're back to here. Fantastic, great. This is what I wanted to see. Okay, let's clean up the code a bit, and then I can end this stream, and I'll post this, make a video of this, upload it to Discord, and then yeah, lots of progress was made today. This was good. Actually, yeah, maybe maybe I'll like end the stream now, and then we'll make it back up first. We'll have to save what we've done. Actually, before we do that, cleaning up the code is simply a matter of like deleting the comment, deleting some stuff. So let's, and also if we're posting this, we can like forget a lot of this stuff. So let's, if we're posting this, we can delete everything apart from the black here. We'll still keep that. Keep that there, keep that that. The frame rate is high. Even with a big res, even with the max resolution. I guess we've done that to do. And then do that, we then have draw sprite, assembly, and then we can delete like delete the pre-assembly version of it. Okay, that's saved. Let's just compile it for the last time. Check that it still runs, and then we'll be done. Okay, fantastic. So yeah, thanks everyone who like stopped by and who asked some questions. And yeah, I'll make a video of this, record it to the Discord, and then yeah, hope everyone I wish everyone happy programming, and see you later. Bye.